Department of Physics, which was established in 1958, presents St. Joseph's massive open online courses on the topic optics as skill effective course. Myself, Dr. C.H. Praveen Babu, Assistant Professor, Department of Physics, St. Joseph's College for Women Autonomous, Vishakhapatnam, Andhra Pradesh, India, as a skill effective course on the topic optics. The subtopic is Chapter 4 Polarization. In this chapter 4.6, elliptically and circularly polarized light, learning outcomes from this chapter: understand the nature of polarization, superposition of linear polarization. Elliptically and circularly polarized light. Consider a beam of plane polarized light obtained from nickel prism falls normally on a calcite crystal cut with its optic axis parallel to its faces as shown in the figure A. Let A is equal to PQ as shown in the figure B be the maximum amplitude of incident light which makes an angle theta with the optic axis. The plane polarized light on entering the crystal is split up in two components, ordinary and extraordinary. That is, the amplitude of incident plane polarized light is divided into two parts. One, the amplitude of ordinary ray, which have vibrations perpendicular to the optic axis as a sin theta along PO direction. Second, the amplitude of extraordinary ray, which have vibrations along the optical axis as a cos theta along PQ direction. From Huygens theory of double refraction, the ordinary and extraordinary ray produced transverse in the crystal in the same direction but with different velocities as shown in the figure C. On emerging from the crystal, they have a phase difference, say delta, depending on the thickness of the crystal. Thus, we have two waves or two simple harmonic motions having amplitudes a cos theta and a sin theta vibrating along the perpendicular directions along and perpendicular to the optic axis and have a phase difference delta depending on the thickness of the crystal. The equation for such a wave can be written as x is equal to a cos theta sine omega t plus delta. This is the equation for extraordinary ray, and equation 1. Y is equal to a sin theta sine omega t for ordinary ray as equation 2. Let a cos theta is equal to small a and a sin theta is equal to small b. Therefore, x is equal to a sin omega t plus delta as equation 3 and y is equal to b sin omega t as equation 4. From equation 4, sin omega t is equal to y by b, and from the general formula sin square theta plus cos square theta is equal to 1. From this, y square by b square plus cos square theta is equal to 1. Keeping cos square theta one side and taking y square by b square to the opposite side, then it becomes 1 minus y square by b square. Finally, taking square to the opposite side, then it becomes cos theta is equal to square root of 1 minus y square by b square. So finally, cos omega t is equal to square root of 1 minus y square by b square. From equation 3, x by a is equal to sin omega t cos delta plus cos omega t sin delta. Therefore, x by a is equal to y by b cos delta plus square root of 1 minus y square by b square sin delta. So here we substitute the value of cos omega t, or x by a minus y by b cos delta is equal to square root of 1 minus y square by b square sin delta. Squaring on both sides, x square by a square plus y square by b square cos square delta minus 2x by a y by b cos delta is equal to 1 minus y square by b square sin square delta, or x by a square plus y square by b square cos square delta minus 2x by a y by b cos delta is equal to sin square delta minus y square by b square sin square delta. Or finally we can write as x square by a square plus y square by b square cos square delta plus y square by b square sin square delta minus 2 x by a into y by b cos delta is equal to sin square delta. In previous equation, we can take y square by b square as common. So finally we can write as x square by a square plus y square by b square into cos square delta plus sin square delta minus 2x by a into y by b cos square delta is equal to sin square delta. We know that cos square theta plus sin square theta is equal to 1. Same thing, if we substitute here, we can write as x by a square plus y by b square minus 2x by a y by b cos delta is equal to sin square delta as equation 5, and this is the general equation of the ellipse. Special cases: when delta is equal to 0, sin delta is equal to 0 and cos delta equal to 1. Substituting these values in equation 5, we get x square by a square plus y square by b square is equal minus 2x by a y by b is equal to 0. This equation can be written as x minus a minus y by b whole square is equal to 0. Now taking the square to the opposite side, then it becomes x by a minus y by b is equal to 0. Now keeping y on one side and taking the remaining to the opposite side, then it becomes y is equal to bx by a as equation 6. This is the equation of a straight line. Therefore, the light will be plane polarized light and vibrations in the same plane as incident light as shown in the figure A. Special case 2, when the delta value becomes 2n plus 1 into pi by 2, where the values of n is equal to 0, 1, 2, 3, so on, the delta becomes pi by 2 minus 3 pi by 2 minus 5 pi by 2, so on. We know the equation 5, x square by a square plus y square by b square minus 2x by a into y by b cos delta is equal to sin square delta. Since cos delta is equal to 0 and sin delta is equal to 1, x square by a square plus y square by b square is equal to 1 as equation 7. This represents the equation of a symmetrical ellipse. Thus, The emergent light in this case will be elliptically polarized as shown in figure B and D. Here the delta values in figure B is pi by 2 and the delta value is 3 pi by 2. In both these cases it is elliptically polarized. In case 3, when delta value is equal to pi by 2 and A is equal to B, then from equation 5 it becomes x square plus y square is equal to a square. This represents the equation of a circle. Thus, the emergent light will be circularly polarized. This happens when the theta value is equal to 45 degrees. That is, the incident plane polarized light on the crystal makes an angle 45 degrees with the direction of an optic axis as shown in the figures F and in the figure G. Here we are getting plane polarized light having the same amplitude. Case 4, for all other values of delta, the nature of vibrations will be as shown in the figure, thus in the polarized light. In the figure C and in figure E, that is, if the light vector vibrates along a straight line, it will be a plane polarized light. If the light vector rotates along a circle, that is, does not change magnitude while rotating, it will be circularly polarized light. If light vector rotates along the ellipse, that is, changes in magnitude while rotating, it will be elliptically polarized light. Applications and significances of circularly and elliptically polarized light. Optical communication, remote sensing and imaging, quantum technologies. From this chapter 4.6, elliptically and circularly polarized light, what have we learnt? Creation and manipulation of polarized light, applications and significance of elliptically and circularly polarized light.